Welcome to K11 Software Solutions AI-powered test automation playlist. In this session, leveraging AI for end-to-end testing in hybrid environments, we'll examine strategies, tools, and architectural patterns for applying AI to large-scale end-to-end test automation.
We're really going to dig into the core strategies and the architectural blueprint for getting this done right, especially when your systems are, just incredibly complex.
All right, so here's our roadmap for today. We'll start by defining the hybrid testing challenge, what it is, and why it's such a headache. Then we'll walk through a blueprint for an AI-powered architecture designed to solve it. After that, we'll get into the good stuff, the key enhancements AI brings to the table. And finally, we'll look at the realities of adoption and what the future holds.
Okay, so let's jump right in with the core problem. Why is testing modern applications so difficult? Well, if you boil it all down to one word, it's complexity. Think about a typical enterprise system today. It's not just one single application anymore, is it? No way. It's this massive, complex ecosystem. You've got your old-school, on-prem legacy apps trying to talk to brand-new cloud microservices, which are then feeding mobile and web front ends, all while pulling data from different databases and third-party tools. It's a huge, tangled web of technology, and it's always changing.
And that complexity is exactly why our old ways of testing are just failing us. Your scripts are brittle, right? They break with the tiniest little change. Regression cycles seem to take forever, and when something does fail, finding the root cause across all those different systems, man, that can take days, delaying critical fixes. The bottom line is, we just need a smarter approach.
And that smarter approach is an AI-powered architecture. So let's look at the blueprint for what is really a fundamentally better way to ensure quality.
You can think of the entire flow as a four-stage pipeline. It all starts with the brain. That's the AI test engine. This feeds into the traffic controller, our execution orchestrator. From there, the investigator, or result analyzer, sifts through all the data. And finally, everything feeds right back into your CI/CD pipeline, creating this powerful continuous feedback loop.
So let's break down that first component. The AI test engine really is the brain of the whole operation. It uses machine learning to do all the heavy lifting, automatically generating test cases, creating realistic test data, and here's the really impressive part. It can self-heal scripts when the application's UI changes. How cool is that?
Next up is the execution orchestrator. So if the engine is the brain, think of this as the central traffic controller. And it is so smart. Instead of running every single test every single time, it intelligently decides which tests to run based on code changes and potential risk. This makes your entire process dramatically faster and way more efficient. And once those tests are run, the results analyzer steps in. This is your AI investigator. It digs through mountains of logs, automatically clusters similar failures together, and then performs root cause analysis. So it tells developers not just that something broke, but why it broke and exactly where to look. This just slashes debugging time.
So we've seen the architecture, but what does this actually mean for your team day to day? What's the so what here? Let's dive into the key AI enhancements.
I mean, this comparison says it all, doesn't it? On the left, that's the pain we all know, high maintenance, slow cycles, constant rework. But on the right, you see the AI-powered solution. With self-healing scripts that automatically adapt to changes, you pretty much slash that maintenance overhead and can finally enable true continuous deployment.
And it doesn't just stop at self-healing. AI unlocks a whole suite of other game-changing capabilities. We're talking about prioritizing tests based on risk, generating safe synthetic data so you don't have security issues, and even using predictive analytics to spot failures before they even happen. It can also visually check your UI for consistency, just like a human would, but way faster. And what this all leads to is a fundamental shift in mindset. We're moving away from a world of reactive debugging, finding and fixing bugs after they've already happened, to a world of predictive quality assurance, where we can prevent them from happening in the first place.
Now, this all sounds pretty revolutionary. I get it. But what does it actually take to implement? Let's get practical and look at the real challenges of adoption and what the future holds.
It's really important to be realistic here. Adopting AI is not a magic wand. There are three key challenges you've got to plan for. First, the AI models need data to learn from, which can be tough for brand new projects. Second, integrating these new tools with your existing legacy systems requires some careful planning. And finally, you absolutely must ensure any test data used by the AI complies with all security and privacy standards.
So where is all this technology heading?
Well, today, the big focus is on AI-assisted analytics and that self-healing we talked about. In the near future, we can expect generative AI to create entirely new exploratory tests all on its own. And then, further out on the horizon, we're looking at fully autonomous systems that not only find bugs, but triage them, and maybe even suggest the fix.
So, let's wrap this up with the key takeaways. By leveraging AI, your team can finally scale test coverage across those incredibly complex platforms. You can drastically cut down on maintenance with self-healing automation, and you can improve release confidence with predictive quality insights. Ultimately, this is how you achieve continuous quality at continuous speed.
You know, I think this quote just sums it up perfectly. The technology is here, the advantages are clear, it's time to embrace the shift, test smarter, and deliver faster.
And that brings me to one final question for you to think about. When you consider your own projects, how could adopting even a small piece of this autonomous testing framework completely transform your team's very next release? Thanks for watching.